Okay, in this question, we are going to take a look at a force that has 3 dimensions. So it is negative 24x to the power 7. It is cosine y, cosine z. And then the third component is 8 minus sine y, sine z. Okay, now the first thing we're going to do is actually verify that this force is conservative, because they're saying find the potential, but maybe it's not conservative, then there is no such thing. Okay, so in order to check that a force with 3 components is conservative, we need to find its curl. Okay, so it's going to be this huge determinant with I, j, and k as the first row. Then the partial derivatives, just the operators as they call them. So there is no actual vector. We just like this is an operator that takes a partial with respect to x. And then the last row is the components of the force. Okay, so let's copy that and let's do the check. Okay, so first the ith component. So we're going to cross out the first column, first row, and then we're going to apply the partial to this part. So that's going to be 8 will go away because derivative of a number is 0. Then minus sine y sine z. Okay, so sine z with respect to y is a number, so we keep it. And by the way, the negative is still going to stay. And the derivative of sine y is cosine. So cosine y sine z. The next derivative would going to be this one, right? So we would subtract this one with respect to z. Cosine y is a number, we keep it. Cosine z with respect to z is negative sine. So this is going to be sine z, and that this is just going to turn that into a plus. So don't put a negative in between because it would look like subtraction, which is not what you want. And we do notice that this is 0. So that's good, but it still doesn't mean it's conservative because we have to check the other two. So let's do the jth component that, by the way, comes with the negative. So just remember that. Okay, so we're going to cross out the second column and the first row. Okay, so that is going to allow us to find this guy with respect to y. I'm sorry, with respect to x. So again, 8 goes away. Sine y, sine z also goes away because it doesn't have an x. So that's going to be 0. Minus. Then we are going to do this one. So that one with respect to z is also 0 because it has no z. Okay, so far so good. The first two components are zeros. Let's go ahead and move on to the kth component. So for the kth component, we're going to do this one. With respect to x, doesn't have an x, so it's 0, minus. And then we're going to do this one with respect to y, does not have a y, is 0. So we just showed that curl is 0i plus 0j plus 0k. Okay, so plus minus 0 doesn't matter. Okay, so we just showed that yes, it's conservative. So we can put one big check mark saying yes. Okay, the next step is to actually find the potential. So how do we do that? So if a force is conservative, it is a gradient of something, which we call the potential. But what is a gradient? Gradient consists of partial derivatives, fx, fy, and fz. And so our force that has components P, Q, R this part must be equal to here, must be equal over here, and this one must be equal to Fz. So we're trying to find a function such as the partial derivative of it with respect to x will be P, the partial derivative of it with respect to y will be Q, and with respect to z will be R. So in order to solve for that function, for that f, we need to integrate, right? Because we need to undo the derivative. But this is a partial integration. So our force f, our potential f is going to be integral of p with respect to x. Okay, so let's do that. So what is our p? Negative 24x to the 7. Let's take the integral with respect to x. Okay, so that's not hard. So we're just using power rule. So we get x to the power 8 because we add in 1. And then we divide by 1/8. So that is going to be negative 3x to the power 8. However, this is a big however here. Because this is a partial integration with respect to x, we have to add that plus c. And the c here could potentially have the other two variables in it because you are treating them as constants, right? Y and Z are constants. So is this the whole potential? No. There may be some extra terms that have Y, Z, maybe mixed, maybe just each one, whatever. So we'll see. Okay, next we are going to make the f equal to partial of q with respect to y, partial integral, and see if we can pick up more terms. So this one is cosine y, cosine z. And we are doing the integral with respect to y. Okay, so cosine z is a number with respect to y, we keep that. Integral of cosine is sine. So this is going to be sine y cosine z. And just like we did in the other one, it's going to be plus some constant that possibly has the other two variables, so x and z. So notice how we already see that this guy is that, right? Because we have a term that has y and z. So we did pick up an extra term. Okay, let's see if we maybe we can pick up another term. So now we're doing PQR, which is our last component with respect to z. So our last component is 8 minus sine x sine y. Let me just double check. What it was, sine y sine z, sine y sine z. Sorry about that. Okay, dz. Okay, 8. Integral of 8 with respect to z is not going to be 0. This is not derivative. So number becomes number z. Minus. Okay, sine y is a number, constant multiple. We keep that. Sine z becomes, integral of sine is negative cosine. So this is going to become cosine z, and this minus will turn into a plus. Again, plus something, yet another constant that could potentially have x and y. So all of these three answers must be the same. So first of all, always make sure that the mixed terms match. So mixed terms contain either maybe all three variables or 2 out of 3, some 2 out of 3. So we do have this one and we do have this one, and they match, which is great, because if they did not match, you would be in trouble. But we do have single terms that don't have, they're not mixed terms. So we have this guy that's mixed term. And we also have this guy that's also a mixed term, right? So we are able to pick up these mixed terms from all of the three integrations. And now we want to combine it into one function. So our potential is going to be negative 3x to the 8 plus sine y cosine z, and then plus 8z. Okay, so this, I think, is going to be correct, but actually the potential is no just one function, because we can actually add a number to it. So you can always add like plus 5 or whatever, and it's still going to have the same partial derivatives, right? Because derivative of a number is 0. However, just for the sake of convenience, we usually don't add plus some number. We just keep it as 0. And so in order to do that, just to make sure, we want to make sure that our potential is 0 is 0. So it's not a requirement, but it's just easier to check the answers if that's the case.